And welcome to another episode of ESTV. Today's episode, we're going to figure out some things about seasons on Earth. We know in that amount of time, it's going to be spring. Let's see if we can figure out why. As a way to begin, we're going to ask you to have a notebook or a big piece of paper out. And we're going to ask you to duplicate this chart you see on the board. By the time we're done with some of our demonstrations, you'll be able to complete all the information on that chart. Why don't you go ahead and pause the video and complete this chart now. Let's use these models to figure out why we have changing seasons on Earth. Right off the bat, you'll notice that this globe of the Earth is tilted. That's 98% of the reason why we have seasons here on Earth. This globe is tilted, as the Earth is tilted, 23.5 degrees. Please keep that number in mind. This would be straight up and down, and the actual Earth is tilted 23.5 degrees from being straight up and down. Again, that number is going to be important in a little bit. Now with this model, we have an out of scale model of the sun and the Earth, and we can see that this smaller Earth is also tilted. If we allow this model of the Earth and the sun to operate, we can see that the Earth, of course, orbits the sun. Well, let's notice something about the tilt. The tilt always stays the same. If we were to think of the Earth tilted on its axis, like this pencil, I think we might say that the tilt is towards the sun compared to being straight up and down. And notice the tilt is in this direction. We'll now let the model run, simulating the Earth's orbit. And we're going to ask you to please notice that the tilt always remains in the same direction. In other words, if we stop the model over here, it's still tilted that way, whatever that way means here in outer space. Well, let's put the two of them together. Since the Earth is tilted on its axis and it orbits the sun, our hemisphere will either face towards the sun or away from the sun or someplace in between. Little spoiler alert, you might know, or we'll just throw out at you, that the different hemispheres have different seasons. They have opposite seasons. That's going to be more clear in just a few moments. So when we talk about seasons, unless we say otherwise, we're talking about the northern hemisphere. When we stop the model in this orientation, I think we'd all agree that the northern hemisphere is tilted towards the sun. Since that's true, we get more direct energy from the sun, and it's going to be hotter. This would represent summer in the northern hemisphere. If we allow the model to continue, we'll go 6 months later. 6 months is half a year, therefore half an orbit. We see the Earth, of course, is still tilted, but now the northern hemisphere is tilted away from the sun. It's just intuitive. You can look and see that now the northern hemisphere gets much less energy from the sun. Therefore, it's going to be cooler wintertime. Probably another good time to point out of our opposite seasons. Since the northern hemisphere is tilted away from the sun, at the same moment, the southern hemisphere is tilted towards the sun. Therefore, our winter is going to be their summer. Yes, Earth Science fans, it's as simple as that. Sometimes people wonder about the in-betweens, in other words, autumn and spring. For that, we have to think just a little bit and notice the direction of the orbit. We're going to stop at one of the in-betweens. And you're thinking, well, it's autumn or it's spring. How do I know which one? First, we'll just slide the model like this. And we'll see that the tilt of the Earth is neither towards the sun nor away from the sun, but again, in between. It's either fall or spring. There's one in between, and of course, another is over here. Well, the way to tell which is by the direction of the orbit. We've already agreed that this is winter in the northern hemisphere. Therefore, we think of which one is after winter, but before summer. After winter, before summer is, of course, spring. This would be the position of springtime. Then, of course, summer, and we continue. Well, let's be a little bit more particular now. This actually represents the very first day of summer. And all this is summertime, 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 first day of autumn. Autumn, 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 first day of winter. Winter, 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 first day of spring. And spring, 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 until we're back where we began at the first day of summer. Let's take a look now at what creates the actual moment that one of these seasons begins. As we know is going to happen in this case in a few days for the first day of spring. Back to our model of the Earth. You're about to see some lines of latitude that sound familiar, and you probably never knew why they were on the globe. In this one, we've highlighted the blue line for the equator. Let's please notice we have a green line here for the Tropic of Cancer in the northern hemisphere. Keep in mind the number we asked you to remember. Earth is tilted 23.5 degrees on its axis. The Tropic of Cancer is 23.5 degrees north latitude. And the Tropic of Capricorn is 23.5 degrees south latitude. While we're here, let's point out the Arctic Circle. You've heard of that, but probably wondered why it's on the globe. The Arctic Circle is near the North Pole, and the Antarctic Circle is near the South Pole. We'll explain each of those right now. Let's first describe the Tropic of Cancer and Capricorn. In this position, we've agreed it represents the first day of summer in the northern hemisphere. If we imagine a perfectly straight line from the middle of the sun to the Earth, we know it's striking the northern hemisphere. That's what makes it summer. Well, more precisely, it is striking the Tropic of Cancer. That happens once every year, and that's the beginning of summer. I know you can tell where this is going. When we get around to the first day of winter in the northern hemisphere, the sun's energy is in the southern hemisphere. That's why it's there, summertime. And that direct ray of the sun is striking the Tropic of Capricorn. That happens once a year on the first day of our winter or the southern hemisphere summer. And I know you figured out the in-betweens. On the first day of autumn or the first day of spring, the direct ray of the sun strikes right on the equator. 2 times a year, only on those 2 days. That's why those lines of latitude are there. And finally, how about the Arctic and Antarctic Circle? Well, let's notice when it's the northern hemisphere summer, tilted towards the sun, we go through one rotation of day and night, and near the North Pole, notice it never goes into the nighttime side. There's 24 hours of daylight in our summer. And if we flip around to represent our winter, there's 24 hours of darkness at the Arctic Circle. Of course, the Antarctic Circle would all be opposite. Cool. So to wrap this up, please complete this chart in your notebook. You can go ahead and stop the video, and once you're able to copy this into the notebook, you're all set. We'll see you on the next episode about seasons on Earth.